All right, let's talk about the effects on the dimension of something. If the radius of a sphere is multiplied by 1/3, what is the effect on the sphere's volume and the effect on its surface area? Okay, so again, we're taking the radius times 1/3. So instead of having r, okay, we're going to have r divided by 3. Now you could draw pictures and try this out and see what happens. But I'm also going to show you looking at formulas how we can tell what would happen. So let's write down the formulas for both volume. Volume is 4/3 pi times radius to the 3rd power, and surface area. Surface area is 4 pi times radius squared. Now if we multiplied radius by 1/3, when you take r times 1/3, okay, what changes, or what change does that affect in the volume? Let's start with volume. Okay, so we're saying instead of having the radius, we have 1/3 times the radius. What change does that make? Well, notice if I were to take this to the 3rd power, I get radius to the 3rd. I also have to take the 1/3 to the 3rd power, which means 1/3 times 1/3 times 1/3. Okay, on the top it'd give me 1 times 1 times 1 is 1, and on the bottom 3 times 3 times 3 is 27. Okay, so what is different between the original volume formula and the volume formula when I took radius to the 3rd power? Notice this is the only difference. Okay, I have 1/27. So what happens? It's like multiplying by 1/27. So if you multiply the radius of a sphere by 1/3, it's like multiplying the volume by 1/27. Okay, let's come over here and look at the effect on the formula for surface area. So again, if we replace our radius with 1/3 of that, or 1/3 times r, if we were to square this, again, squaring means to take something times itself. For the r, we just still end up with r squared. But for the 1/3, that means 1/3 times itself. 1 times 1 on top is 1, and 3 times 3 on the bottom is 9. So then we want to look at our differences. What's the difference between the original surface area and this new surface area? Well, notice the only difference between their two formulas is this 1/9. So the surface area is multiplied by 1/9. Okay, if you multiply the radius by 1/3, your surface area is multiplied by 1/9. Your volume is multiplied by 1/27. Okay, what if we triple the radius? What would the effect be then? So let's try the same thing. What would the effect be? This time let's talk about just on surface area. Okay, so the formula for surface area of a sphere, this is a sphere, is 4 times pi times the radius squared. What would happen if we tripled the radius? Now triple means to take it times 3. So instead of r, we have 3 times that. What's the effect going to be? Well, that would mean we have 4 times pi times this 3r squared. And if we square that 3r, r squared is just r squared, and 3 squared, 3 times 3, gives me 9. So now I have 4 times pi times 9 times r squared. What is the change? What's the difference between the original surface area and this surface area with the radius tripled? Well, the difference is right there. It's that 9 that's multiplied in there that doesn't exist here. So what happens? The surface area is multiplied by 9 if you triple the radius. Okay, and notice again, that's whatever we multiply the radius by, surface area squared, so the effect will be that number squared. All right, let's try one more of those. See? So suppose you double the radius. What would the effect be on the surface area? So try that out. Maybe pause, try it out, and then push play and see if you're right. So again, we're dealing with surface area of a sphere. So our formula is surface area equals 4 times pi times the radius squared. If we double the radius, that means to take something times 2. So instead of r, we have 2r. Let's see what happens to our formula if we replace our r with a 2r. Well, if we want to simplify and remove these parentheses, we have to square, which means to take 2 times 2 and r times r. So what has changed with our formula? Here's the original, and here is the new one after doubling the radius. The only difference is this 4. Notice it's not here. Here we're multiplying by another 4. So what's the effect? You're multiplying the surface area by 4. Again, notice whatever we did to the radius, we multiplied it by 2. Surface area is squared, so if we square that, our effect is the number squared.